Well, good afternoon, everyone. Before we begin this presentation, I would like to express my heartfelt gratitude to all of you who sincerely committed to this session to make it a success. This session wouldn't have been possible without the support of each and everyone present here. The topic of discussion for today's presentation is green energy management. I would like to quickly introduce myself. I am Mohammad Aftab Ansari from MCKV Institute of Engineering's Department of Computer Science and Engineering, second year, and together with my fellow batchmates, Sayan Kumar Sadhukhan and Debjit Pal, we are going to present a documentary and future redirection and the technical overlook about the carbon neutrality, the energy crisis, and how we can overcome this. Let's move on to the contents. The contents include the following points: why we can't reduce energy usage, the number is rising year by year, climate change is one growing problem that needs to be solved. What is the renewable energy graph over 40 years? We need to be carbon neutral as soon as possible. Where we can reduce the energy usage, how we can increase renewable energy, the new LoRa module comes to play. Integrate it with every household and commercial meter system. And lastly, reduce the transmission loss significantly and store excess energy for other purposes. Why we are unable to reduce energy usage? The simple answer is that our home has more devices today than it has ever had before. And this multitude of electronics adds up to increased power needs that more than often offset the savings being generated by more efficient appliances and no load electric device requirements. During the COVID-19 pandemic, while many industries were shut down, we would expect this year energy consumption will go down or be at same level as previous year. But in reality, it didn't affect much of the energy consumption and it still increased a little than the previous year. Its predicted energy usage will only go up year by year. Here's a bar chart for a better understanding of the rise in energy usage year after year. Renewable energy production compared to fossil fuel energy is only 20% over the past decade. The growth rate isn't nearly enough for our lofty goal of carbon neutralization. When we go to transit from fossil fuel to renewable energy, the production gap of these type of energy sources sent us on certain energy crisis. We need to see some rapid growth in this sector, but unless we can store energy efficiently, we are unable to do so in real time. Global temperature is rising after the Great Industrial Revolution. Here's a graph to illustrate the rise of global mean surface temperature. It's a serious issue. In 2020, the average annual electricity consumption for a US residential utility customer was 10,909 kilowatt hours, an average of about 909 kilowatt hours per month. The household electricity consumption per capita in India amounted to 207 kilowatt hours in 2016. India is still a developing country and it still needs more energy to continue growing. And if we consider per capita energy usage and the population with the developed country, then we can see there is a lot of growth potential if we provide the necessary energy. In current energy production system, if we consider the coal thermal energy production method, the primary energy conversion efficiency is around 33% in ideal scenarios, where transmission loss is negligible. But that is not the case for many. So there the efficiency drops drastically. If we then use that energy to produce thermal energy, there is 30% further drop of that energy. So we could use very little of what we want. There is a big production loss. India's total transmission and distribution losses have been over 20% of generation, which is more than twice the world average. The ideal level of transmission and distribution losses ranges between 6 to 8%. If anybody uses electric heater instead of heating over CNG gas, then they were wasting over 55% energy just by conversion of energy from heat to electricity to again heat. But from burning gas, there is no unnecessary conversion of energy. Whereas in coal power generation, the efficiency is very low as compared to its high pollution rate. Let's move on to the next topic. Increase the renewable in small scale is very effective. Not only we can use more space of power generation, we can save transmission losses significantly. In case of solar power, we use our roof space efficiently, wherein large scale solar energy production is not very efficient, where we used up a lot of land resources, where the per capita land available in India is very low. When we build the solar panels over canals, we decrease water evaporation rate of the canals and we maintain a certain temperature of the panels. In that way, electricity production is way efficient than normal rooftop solar or over land solar. That's why many countries are now starting to build their solar plant over huge water bodies. In deserts, the molten salt solar power generation plant is more efficient than the normal solar panel. The high temperature is very efficient for generating electricity, where the molten salt temperature is around 600 to 800 degrees centigrade. In India, we have a great amount of coastal line. We have a coastline of 7,516.6 kilometers in total, of which 5,422.6 kilometers of mainland coastline and 2,094 kilometers of island territories. In high elevation area, where the wind travels uninterrupted, there is a good chance of producing electricity by building wind turbines. We can use micro and mini hydropower plants where we have monsoon climate. It won't affect the nature much and we still can generate electricity. In Meghalaya, where it rains 365 days of the year, we won't need to worry about being unable to produce electricity due to water shortage in those mini and micro hydropower plants. Let's play a video for a better understanding of the idea. By storing the excess energy as hydrogen fuel, we could use it as a power generation method for energy for emergency or as a transportation fuel of trucks or other transportation system. As hydrogen is most abundant element of the universe, we We just need to perform electrolysis of water to get this element. And we also get the oxygen as another byproduct that we could use in industries like steel production plants. Our dream is not unrealistic because there is a particular location where the population have witnessed the overproduction of electricity. That location is Orkney Island, with an area of only 990 square kilometers, where they need 7 to 47 megawatts depending on what time of the year. But from 2013, they experience a total of 130% of the power generation by renewable energy. Those energy sources are wind, wave, and tide. Currently, they produce 2000 megawatts tidal and wave energy, 17,000 megawatts offshore and wind current, and they are unable to utilize this energy fully. If an island with an area of only 990 square kilometers can be able to achieve these things, then every other country would be able to achieve this. It is not a dream anymore. Next, I would call upon my friend Sayan to come before and discuss about the next topic, LoRa.
Thank you, Aftab. Hello and good afternoon, everyone. This is Sayan Sadhukhan, and now I'm going to discuss about LoRa and how it is relevant for energy management purposes. Introduction to LoRa. It is a very important to use the energy generated by small-scale power generation area efficiently to reduce transmission loss. By using small-scale power generation plant to local community will be self-sufficient on energy. By achieving it, we can be able to provide uninterrupted drinkable water service 24/7 to every household, which is a common thing for a developed country. With a population of 1.38 billion people, India is the second most populous country in the world. More than 6% of this population lacks access of safe water sources. By using LoRa with IoT, we could develop a system that could not only provide the energy we need in daily life, we could use excess energy to make hydrogen fuel for transportation and other purposes like a backup solution. What is LoRa? LoRa is a spread spectrum modulation technique derived from chip spread spectrum technology. LoRa devices is a long-range, low-power wireless platform. With the help of this technology, we can place the sensors in the locations without internet or Wi-Fi connectivity and can receive the data via LoRa gateway, and it can be sent to internet. By this way, we can monitor the real-time census data from anywhere. While LoRa is the physical layer, LoRaWAN is an open source, cloud-based protocol designed and maintained by the LoRa Alliance that enables devices to communicate wirelessly and with LoRa. Essentially, LoRaWAN takes LoRa wireless technology and adds a networking component to it, while also incorporating node authentication and data encryption for security. Here is the implementation of TCP/IP protocol of the LoRa system. The listed points are the uses and reasons why we are using the LoRa module. Let's talk about them. LoRa range facilitates deep indoor coverage. Low power consumption means longer battery life. High capacity of handling message per gateway. Low cost due to minimal infrastructure and open source nature of LoRa. Has the ability of geolocation without the needs of GPS, both indoor and outdoor, with no impact on battery life. Firmware updates over the air. Seamless roaming from one network to another. Enhanced security measures like AES 128-bit encryption and a unique ID. The picture indicates the time on air transmission for Class A, Class B, and Class C types. How the LoRa works other than meter system where we could be able to use it. Gateways comprise of single channel and multi-channel gateways. Single channel gateways can only receive on one channel and one spreading factor at the same time, while multi-channel gateway is a full gateway and can receive on 8 channels. Some even have 10 and 6 spreading factors at the same time. This is a picture of the LoRa module that we are talking about. The module shown here is a RAK2245 Pi hat with an 8-channel gateway. Now Debjit is going to elaborate further. I request you to come before and talk about it.
Thank you, Sayan, for letting me elaborate further on this technology. Hey everyone, and good afternoon. This is me, Debjit, and I'm excited to talk about the emerging technology LoRa. I'm going to talk about the working concept of how we can use the technology and its deployment strategy. Working concept of how we can use LoRa with an electric meter. First, the sensor nodes contain different sensors that captures the data from the electric meter and it's transmitted over LoRa to the gateway. The gateway receives the data, sends it to the cloud server via MQTT protocol. We could use a Docker-based Ubuntu Linux server hosted on Microsoft's Azure virtual machine. It contains 4 major containers. The first one being Mosquito MQTT, which acts as an MQTT protocol server for receiving sensor data from the electric meter. The second one is Noded, which is a middle layer application server to process the incoming data and submit the incoming sensor data to the databases. The third one, MariaDB or InfluxDB, which are databases to store the time series based data from sensors. The last one being Grafana, which acts as a web-based front end to visualize the real-time data. Moving on to the set of tools or technologies we can use to develop the whole system. Azure, MariaDB, Grafana, Mosquito MQTT, and Node-RED. The backend of the system comprises of Azure, which is a cloud computing service created by Microsoft for building, testing, deploying, and managing applications and services through Microsoft-based data centers. And Docker, which is an open platform for developing, shipping, and running applications. Let's elaborate further on the different technologies or tools used in building this project. MQTT protocol, Mosquito. MQTT is an OSI standard messaging protocol for the IoT. It is designed as an extremely lightweight, published or scribed messaging transport that is ideal for connecting remote devices with a small code footprint and minimal network bandwidth. Eclipse Mosquito is an open source message broker that implements the MQTT protocol. Backend handling with Node-RED. Node-RED is a flow-based development tool for visual programming developed originally by IBM for wiring together hardware devices, application programming interfaces, and online services as a part of IoT. Node-RED provides a web browser-based flow editor which can be used to create JavaScript functions. Database management system, MariaDB. It is a community-developed, commercially supported fork of the MySQL Relational Database Management System intended to remain free and open source software under the GNU General Public License. And the last tool, that is a web application to visualize the whole system, Grafana. Grafana is a multi-platform open source analytics and interactive visualization web application. It provides charts, graphs, and alerts for the web when connected to supported data sources. What are the advantages of developing the system with LoRa? The advantages being low power sensors and wide coverage area measured in kilometers. Single LoRa gateway device is designed to take care of thousands of end devices or nodes. Long range, which enables solutions such as smart city applications, and low bandwidth, which makes it ideal for practical IoT deployments with less data and with data transmissions which aren't constant. These are the references used for building this presentation. You can visit the links provided below to have a delight insight of the things discussed throughout the presentation. We appreciate your involvement and thank you for sparing the valuable time for the session. We are sure that by participating in the session, you have gained useful knowledge and new innovative ideas. We would also like to thank our teacher for giving us the opportunity to present our concept of future energy sector and our involvement as a technical student as the digitization of the daily life continues to grow and we need to solve the energy crisis as soon as possible. Because the fossil fuel is not going to last many years in the future, and if we would not save the climate, that's not the only reason to go for clean green energy as the fossil fuel is near its end. Thank you.